Hello, our presentation today is by Victor Olivo, Andres Jimenez, Aaron Sanchez, and Ricardo Guerra. Our research question is, how does nuclear exposure affect us in regards to physiological and ecological concerns? After reading In Order to Live, we took interest in how the North Korean government has people in poor conditions and how they continue to bring harm to their own citizens. One of the many harm factors we found is nuclear exposure. We wanted to find the effects of nuclear exposure in North Korea, however we couldn't find enough information deemed useful, so we instead looked into the overall physiological and ecological effects of nuclear exposure. We agreed the topic of nuclear exposure would be something interesting to research, and we wanted to become more aware of the effects. Some of the things we already know that can relate to the topic are that nuclear testing is linked to some types of cancer and seismic activity. Some of the minerals used in nuclear weapons are uranium and plutonium, which are obtained through the process of fracking. Fracking in turn increases the risks of earthquake, affects air emissions, water, land, and more. A lot of the sources we found contributed in some way into our research. They definitely gave us ideas as to what to look for.
Of radiation exposure on human tissue caused by 5 to 5,000 REMs. REMs are the absorbed dose multiplied by the quantity factor of the type of radiation. REMs are a unit used to measure how much damage radiation has done to human tissue. With beta and gamma radiation, the absorbed dose is equal to the equivalent dose. With alpha and neutron radiation, the absorbed dose is less than the equivalent dose. This is caused by the different ways each radiation type reacts to human tissue. With beta and gamma radiation, they more easily just pass through human tissue, but for alpha and neutron radiation, because of their higher energy and tendency to linger in human tissue, they tend to do more damage. Dose REM 5 to 300. 5 REMs would be the equivalent of full body exposure of a radiation worker per year. Since radiation tends to affect soft tissue first, the intestinal tract, bone marrow, and blood vessels would be the first to be affected, causing symptoms of stomach sickness, weakening of the immune system, and hemorrhaging. Since reproductive tract cells divide rapidly, these areas of the body can be damaged at REMs as low as 200. Long term, some radiation sickness victims will become sterile. Dose REM 300 to 5,000. Since the brain is essentially a large mass of soft tissue and the fact that brain cells do not reproduce, death will most likely be caused by brain damage or a common illness like the flu, because of the destruction of soft tissue bone marrow, essentially destroying your immune system, leaving you very vulnerable to even common ailments. At this point, death is a matter of days or weeks. Cases of 1,000 to 5,000 REMs are the most rare because to be exposed to that much radiation, you must be at the center of where the bomb dropped. But being that close would normally mean near instant deaths from the initial blast. Most of these cases are victims of nuclear meltdowns.
In the first milliseconds of Little Boy's detonation, electromagnetic energy in the form of gamma rays, neutrons, and X-rays sprays up to 2 miles in every direction. The waves and tiny particles, invisible and odorless, bombard anyone exposed with cell-damaging energy. For almost all within a half mile, the rays are deadly.
How does nuclear radiation affect the ecology? Just like humans, plants and animals are also affected by nuclear radiation. For instance, the organism's chromosome structure can be changed, which means that their DNA can become damaged through mutations, possibly causing cancer. Their rate of growth can be altered, its reproduction rate could decline, its offspring can become abnormal, Affected organisms can die immediately or suffer from a lower life expectancy. And lastly, the organisms can receive severe burns to its tissue. Radioactivity can be transferred from infected plants to people and animals. Even though low levels of radiation can be beneficial to the environment, large levels can be very harmful. If a nuclear bomb is set off underground, it can create a crater up to 1,280 feet in diameter and 320 feet deep. Fallout produced by the explosion can make the area dangerous for many decades. For example, Chernobyl is still considered very dangerous even though it happened about 30 years ago in April 1986. Furthermore, water in plants that were not close to the site can still become contaminated with the isotopes in the air or transferred to other regions due to rain.
When conducting the research, we found it difficult to find material on one specific country, but we concluded the ecological and physiological effects would be identical regardless of the nuclear test location. Most of the credible information we gathered was found in books and articles. During our research, we gained knowledge on how nuclear tests have a wide range of effects across different forms of life. The people and ecosystems around nuclear testing sites are vulnerable to illness and nuclear contamination due to large amounts of radiation exposed to the surroundings during these tests. We also learned that radiation emitted from these nuclear blasts can linger in the Earth's atmosphere, not only affecting us, but also generations to come. With the knowledge gained from this research, we can apply it to our future by being more informed on nuclear tests conducted by the US or other countries and the effects they might have on our own lives. If any nuclear disaster were to occur in the future, we would have better insight on what effects it would have on our community and environment.